Welcome to GenAI Level Up, the podcast where we decode the future of artificial intelligence one breakthrough at a time.
Whether you're just starting your AI journey or you're a seasoned expert, you've come to the right place. Our mission is to make the complex world of generative AI accessible to everyone, everywhere.
In each episode, we dive deep into the foundational concepts, the latest research, and the transformative applications that are shaping our world. It's time to get smarter, faster. Let's level up together.
So the problem with artificial general intelligence, AGI, it isn't just about, figuring out how to build it. For decades, the real hang-up has been defining it. AGI has always felt like this constantly moving target. Every time AI masters something complex, we thought only humans could do, generating amazing art or writing legal stuff or passing medical exams.
If I just shift the goalposts again.
Exactly. We say, nope, that's not real general intelligence. Real intelligence is the thing it still can't do.
And that persistent ambiguity, it's actually been incredibly damaging, hasn't it? It really muddies the waters.
Yeah.
It obscures the actual technical gap between today's AI, which is super specialized, and true adaptable human-level thinking. It leads to those completely unproductive debates, is AGI next year or, next century?
Right.
But our sources today, they introduce a really comprehensive, actually quantifiable framework, something designed to cut right through all that noise.
Okay, so the mission here is clear then. We need to stop talking about AGI like it's some mystical future thing and start treating it like a measurable engineering problem.
That's the idea.
So how do they define it concretely in these sources?
Well, it's defined relative to the benchmark we know best.
Us.
Humans. AGI is an AI that can match or even exceed the cognitive versatility and proficiency of a well-educated adult.
A well-educated adult. Okay.
And crucially, the sources define the AGI state as hitting 100% proficiency across a really broad range of cognitive skills. They prioritize versatility, that ability to adapt and use knowledge across different areas, rather than just being amazing at one single thing.
That seems like a pretty solid target.
Yeah.
But how do you actually measure cognitive versatility in a machine? It sounds a bit like you're trying to give a giant language model an IQ test. Isn't comparing an LLM to a human mind just like apples and oranges?
That skepticism is totally fair, but the methodology here kind of sidesteps that apples to oranges trap. It grounds itself in, established human science. They use the most empirically validated model of human intelligence we have, the Cattell-Horn-Carroll theory, or CHC theory, of cognitive ability.
CHC theory. Okay.
Yeah, so this isn't just some arbitrary quiz they made up. It's a really rigorously developed hierarchical model. It breaks down general intelligence into distinct, broad abilities and then hundreds of specific, narrow ones.
Okay, so they basically took decades of human psychometric research, the kind of gauntlet humans go through to assess intelligence, and they adapted it to actually evaluate these large language models.
Precisely. And this approach, it replaces those fuzzy, nebulous concepts with concrete, systematic measurements. The end result is a standardized AGI score, running from 0% up to 100%.
Where 100% is the cognitive equal of that well-educated adult benchmark.
Exactly.
And the scores themselves are immediately revealing, aren't they? The framework applied to the current frontier models, it shows this incredibly rapid, almost dizzying progress, but also a really profound gap that's still there.
That's right. Models from, say, 2023, like GPT-4, they scored around 27%. But the newest iteration, GPT-5, it leaps way ahead to an estimated score of 58%.
Wow, 27 to 58%. That really quantifies both the huge achievement and the substantial task still remaining.
It really does.
Okay, let's unpack this score then. Let's see what's truly driving those numbers.
Right. So to hit that 100% target, to get that cognitive versatility of a highly functional adult, the AI needs breadth.
Right, not just depth in one area.
Exactly. The framework tests the AI's performance across 10 core cognitive domains. These 10 domains, they come directly from those CHC broad abilities we mentioned, and they're weighted equally, 10% each.
Equal weighting. So if you ace math, get 10%, but score 0 in memory.
Your overall score gets severely penalized. It forces the AI to be an all-rounder, not just a specialist.
Makes sense. It has to be versatile.
Yeah.
So tell us about these 10 foundational dimensions. What makes up this whole cognitive package they're measuring?
We can kind of group them thematically. First, you've got the foundational knowledge and basic skills.
Okay.
This includes general knowledge, which
Wow.
covers the breadth of factual understanding, common sense, culture, science, history. Then you have the instrumental skills, reading and writing ability for language proficiency,
Actually.
and mathematical ability, covering everything from basic arithmetic up to complex calculus.
Okay, so that's the sort of static knowledge base. What about dynamic thinking? How does it handle new stuff?
Right, that's where on-the-spot reasoning comes in. This is about the flexible control of attention you need to solve genuinely novel problems.
Like figuring things out.
Exactly. It's tested using tasks that need deduction, induction, even simulations of social understanding, what people often call theory of mind. This domain really checks if the AI can adapt its logic on the fly.
And memory, of course.
Mm.
Humans don't just have one kind of memory, do we? We have
Yeah.
different systems working together.
Precisely. The framework breaks memory down into three crucial, distinct systems. There's working memory, WM. That's the short-term holding and juggling of information. Think of it like the context window size, sort of.
Okay, the scratch pad.
Yeah. Then you have long-term memory storage, MS. This is really critical. It's the capacity to continually acquire and stabilize new information from recent experiences. Learning, basically.
Got it. And the third?
And finally, long-term memory retrieval, MR. This tests the precision and fluency of accessing all that vast stored knowledge without mixing up facts or just making things up confabulating.
Ah, the hallucination problem relates to MR then.
Directly. And the final set of skills focuses on interaction and processing speed.
How it deals with the world.
Yes, the AI needs to process the world efficiently. This includes visual processing V, auditory processing A, and finally speed S, which measures processing fluency, simple reaction times, and just how quick it is at basic tasks. What's really fascinating here is that the AI is being tested with the same fundamental cognitive batteries, the same kinds of tests used for humans. It means the comparison is actually pretty scientifically rigorous.
So let's look at those performance profiles. Because you said the 58% score is built on a highly jagged cognitive profile. Where are these frontier models, especially GPT-5, showing their really tremendous strength?
Well, they really shine in areas that directly leverage that massive scale and all the static training data they have.
Makes sense.
So in general knowledge, or K, both models are already incredibly strong. GPT-4 scored 8% out of the possible 10%.
Pretty good.
And GPT-5 nudged that up slightly to 9%. So that confirms they have a really robust, high school level or maybe even better understanding across history, science, culture.
And reading and writing. That seems like something language models should ace. Is it essentially solved?
Almost entirely, yes. In reading and writing ability, GPT-5 achieved a full 10%. Perfect score.
Wow.
The sources noted that previous generations, like GPT-4, sometimes struggled a bit with lower-level tasks like tracking comprehension across really long documents or ensuring perfect subword recognition, that kind of thing.
Little glitches?
Yeah, but GPT-5 seems to have basically ironed out those kinks. It shows mastery of composition, comprehension, and error-free English usage.
Okay, so near perfect on knowledge, perfect on reading, writing. But the most dramatic leap highlighted in the sources you mentioned is in mathematical ability.
Oh, it truly is astounding. GPT-4 was, frankly, surprisingly limited here. It only scored 4%.
Only 4% for GPT-4.
But GPT-5 achieves a perfect 10%.
10% from 4.
From 4 to 10. This means it shows reliable human-level proficiency across all 5 math areas they measured. Arithmetic, algebra, geometry, probability, and calculus.
Calculus.
Yes, including solving complex, competition-level problems that previously needed specialized tools or definite human intervention.
Wow. Going from 4% to a perfect 10% in mathematics, that's a massive specialized strength developed in basically one generation.
It's a huge jump.
Okay, but here's where that score gets really interesting, right?
Yeah.
You've got perfect 10% scores in math and reading and a 9% in knowledge. Add that up, that's 29% already covered flawlessly. So why is the overall score still only 58%? That implies some really profound weaknesses lurking underneath all that strength.
And that's exactly right. We now have to focus on what the sources call the critical deficits in foundational cognitive machinery. This is what truly separates the current AI from that well-educated adult benchmark.
Okay, where do we start? What's the biggest hole?
Let's start with what the sources call the most significant bottleneck, and that is the deficit in long-term memory storage. or MS.
Okay, MS, what's the score look like there?
The score here is, well, it's brutal. A flat 0% for both GPT-4 and GPT-5.
Oh, hold on. 0%. Not like 1% or 2%.
Yeah, 0. This is singled out as the single biggest defect. Long-term storage, remember, covers associative, meaningful, and verbatim memory. It's the ability to learn from experience and actually retain that learning beyond the current chat window, beyond the current interaction.
So, wait. 0% means the moment the conversation ends, or maybe even just when the context window scrolls past. The AI essentially forgets everything that just happened, who it was talking to, what it learned 5 minutes ago, any context it was given that wasn't in its original training data.
That's the implication.
It's not just poor memory. That's like complete cognitive amnesia after every interaction.
It is a fundamental defect. The AI cannot stably acquire or store new information that isn't part of its training. It forces the AI to essentially relearn its context, its personality, if you will, in every single new interaction.
Wow.
That fact alone, that 0% score, fundamentally undermines the comparison to a functional human mind.
Yeah, I could see that. Okay, what about the other side of memory retrieval precision, getting the information back out correctly?
Right. That's long-term memory retrieval, and both models score low here too, achieving only 4% overall.
Only 4%. Why so low?
Well, they have high fluency. They can generate text quickly, confidently, sounds good.
Yeah, they sound convincing.
But they fail critically on precision. That's the ability to check facts against reality and avoid, well, confabulation, what we usually call hallucinations.
Ah, okay. Like that classic example mentioned in the sources, right? Where both models couldn't recognize that Napoleon never campaigned in South Africa.
Exactly.
And they just confidently spin this plausible but totally false story about it.
Precisely. It's a failure of factual grounding. They prioritize sounding fluent over actually being accurate.
Okay, so major memory issues both in storing and retrieving reliably. Next, let's look at that flexible problem solver, on-the-spot reasoning. How does the AI do when it faces genuinely new problems?
Surprisingly low, actually. GPT-4 scored 0% on reasoning.
0 again.
0. And GPT-5 only managed to get up to 7%.
Still quite low, considering how smart it seems otherwise. Why?
Well, this deficit relates to more sophisticated thinking processes, things like induction, which is figuring out abstract rules just from seeing examples, and adaptation, the ability to infer unstated rules from feedback, the kind of continuous iterative learning a human does when faced with, say, a confusing new software interface or a tricky social situation.
So they struggle to genuinely grapple with new rules and constraints on the fly.
They still seem to struggle with that, yes.
And finally, rounding out these weaknesses, you mentioned the speed and multimodal components.
Yeah, if we look at visual processing, V, auditory processing, A, and speed, S, the scores are all clustered down near 0.
How low?
Well, GPT-4 scored 0% on both V and A. Just couldn't do it. GPT-5 made some progress, scoring 4% in visual and 6% in auditory.
Okay, some progress is good.
It is, but it still represents, well, essential cognitive incompleteness. We're talking about major deficiencies in tasks like visual reasoning, things like mentally folding paper, or truly embodied spatial understanding and complex auditory skills, like phonetic coding or understanding rhythm.
So even with GPT-5's advances, cognitively speaking, it's still essentially partially deaf and partially blind to the world, and slow at basic comparisons.
That's a fair, if blunt, summary. And the speed score confirms this. Only 3% for both models.
3%.
Yeah. While they can spit out text tokens really quickly, their fundamental integrated processing speed across different modes is either non-existent or just far too slow to match a human mind reacting to stimuli in real time.
Okay, so we have these incredible strengths, but also these profound foundational weaknesses, especially the 0 score and long-term storage. Yet the AI industry still manages to make these models do useful work, right? People are using them.
Absolutely.
The sources address this, don't they? They talk about capability contortions used to sort of mask the underlying problems.
That's a key point. These workarounds, they create a kind of brittle illusion of general capability. It looks more capable than its underlying cognitive structure really is.
Okay, give us an example. How do they work around the 0% in long-term memory storage?
The primary contortion there is the massive reliance on huge context windows, essentially maximizing the working memory WM component.
So they use a gigantic notepad to manage the state and simulate persistence across a conversation. They don't actually remember. They just keep rereading the entire transcript, essentially.
That's a good way to put it. And it's computationally incredibly expensive and wildly inefficient compared to human memory.
Yeah, I bet.
The sources are pretty clear. This method just cannot scale to tasks that require context built up over days or weeks or months, stuff a human manages easily. It's a temporary patch, a Band-Aid that doesn't fix the underlying memory architecture issue.
Okay, and what about mitigating those hallucination issues? The poor retrieval precision, the MR problem.
That's where they often integrate external search tools. You hear about retrieval augmented generation, or RAG.
RAG, right? Bolting on a search engine.
Basically, yeah. This masks the inability of the core model itself to reliably access its own static parametric knowledge without making stuff up. But crucially, RAG retrieves discrete facts. It does not constitute genuine personalization or the kind of evolving dynamic memory acquisition that humans use constantly. It's another clever workaround.
Which brings us back to that engine analogy you presented in the source. It's a good one. Overall intelligence is like horsepower, right? But an artificial mind is ultimately limited by its weakest components.
Exactly.
So current AI might have a perfectly tuned carburetor, that math score of 10%, and a great paint job with a reading score of 10%. But if the engine block itself is missing a critical piston, that long-term storage at 0%, the overall performance is capped, bottlenecked by that defect.
That's the core idea. And if we connect this to the bigger picture, achieving true AGI, getting that 100% score, is really about solving these fundamental underlying cognitive challenges. Memory, precise retrieval, flexible reasoning.
It's about fundamental architectural fixes, isn't it? Not just scaling up the training data for the parts that already work well.
Exactly. It's not just about making the strong parts stronger, it's about fixing the broken parts.
So, okay, to summarize for you, the listener, the two really key takeaways from this deep dive seem powerful. First, AGI now has a concrete, psychometrically grounded definition matching the cognitive profile of a well-educated adult. No more moving goalposts, hopefully.
That's the aim.
And second, the current models, even the impressive GPT-5 at 58%, have this severely jagged cognitive profile, defined by really high performance in static knowledge and skills, but crippled by critical structural deficits in foundational systems. Most notably, that shocking 0% score in long-term memory storage.
That really sums up the current state according to this framework. And maybe here's a final provocative thought for you, building on the source material.
Okay.
We've established that this AGI definition, the 100% score, focuses purely on achieving human-level cognitive versatility, matching a human mind. However, the sources also explicitly list replacement AI as a distinct concept.
Replacement AI, how's that different?
They define replacement AI as an AI that performs almost all economically valuable tasks more effectively and affordably than human labor. It's about economic impact, not cognitive architecture parity.
Okay, that raises a huge question then. Is it possible for an AI to be massively economically disruptive, to become a replacement AI, even if it's still cognitively impaired by this framework's standards, even if it's stuck at, say, 58% or 70%?
Well, think about it. An AI that solves math and writing perfectly, but relies heavily on giant context windows and RAG search to mask its terrible memory and reasoning deficits. That AI could still be profoundly useful and maybe cheaper than a human for many companies, couldn't it?
Yeah, absolutely. For many specific jobs, maybe you don't need perfect human-level versatility.
Right. So if an AI achieves 100% on this AGI score, it's arguably a versatile human-like mind, but we really have to consider, could the economic consequences of a replacement AI actually arrive before we achieve that 100% score on the human mind benchmark?
Meaning, we could get the massive societal disruption without actually having built a truly general intelligence first.
It's possible. And what does that imply about the priorities of AI development right now? Are labs truly focused on building a complete versatile mind, or are they maybe more focused, consciously or unconsciously, on building a tool that displaces labor effectively, even if it's cognitively flawed?
That is definitely something to mull over as we watch the progress toward that 100% score, or perhaps towards something else entirely.
Well,
Keep exploring this fascinating space, everyone, and thanks for taking this deep dive with us.
And that brings us to the end of another deep dive into the world of generative AI.
Thank you for tuning in to GenAI Level Up.
If you found this episode valuable, please consider subscribing and leaving a review on your favorite podcast platform. It helps us reach more curious minds like yours.
Join us next time as we continue to explore the cutting edge of artificial intelligence. Until then, keep learning, stay curious, and continue to level up.